Good evening. Now we will see the remaining three questions that is from assignment 7. So we have 7 question. A discontinuous strut of length 2.5 meter consists of two unequal angles ISA 8058 and is connected to a 10 mm thick gusset plate by its longer leg on opposite side of the gusset plate where KL is given 0.85 L. Assume steel Fe410 and strength of the strut will be. So now properties of the section that are given. So we have L effective that is given 0.85 L. L is given 2500. So we have L effective 2125. Now L effective upon R minimum. So we have this value that is 22.15. So we have calculated actually this value by RYYW, which is RYY individual square plus CYY plus thickness of gusset plate by 2 whole square. And by solving this, we are going to get RYY whole as 22.15. And then from this, we have angle section, built up section, and we have buckling class C. So we are using table 9C. And from 9C, we have value that is for 95 and 100. So you can see this value for 95 and 100. So we have these values. So you can see over here. So we have KL upon R and FCD. So KL upon R we have 90 and this is 121. And then we have 100 and for 100 we have 107. And from this we have calculated value for 95.94 and we got this value that is equal to 112. Actually one term that was remained over here 121 minus, and in that one we have actually hold these values, and that will gives me FCD 112.68 Newton per mm square. And from this we can find PD 2 into 112.68 into 978, because area is given 978 mm square, and that will give us 220.41 Newton. That is 220.41 kilonewton. And 220, that means that is in portion, that is between 219 to 223. So we have answer is C. Then we have next an ISA 130 130 used as a strut has a length between the intersection at each end as 3.5 meter and the yield stress Fy 250. It is connected with gusset plate by 2 bolts at each end. Then the equivalent slenderness ratio will be. So now single angle is given. So we have to find value of lambda E equivalent slenderness ratio. And we have this value. So we can see this lambda E, we have this formula. Now K1, K2, K3 we have to use, that is if we will go to IS 800, we have that as table number 12. And from this we have to get value of K1, K2, number of bolts, and that is fixity accordingly. So that as they have mentioned, assume fixed condition, and bolts also they have given 2 bolts. And for that one we have formula that is L upon RVV and divided by root of, here we have epsilon value 1 pi square E upon 250. And from this we will get value of lambda VB 1.53. So formula you can have lambda VB here. So I have not actually written over there. So we have lambda VB here and then we have lambda 5. So lambda 5 130 plus 130, and from this we will get, so this value we have actually lambda 5 or lambda 5 we can say, and we have this value 0.146. Now substituting values of K1, K2, K3, so we have these values given for 2 or greater than 2 fixed condition 0.2, 0.35 and 20. And if we will put these values, so formula is K1 plus K2 lambda square VB plus K3 lambda 5 square. So accordingly we have substituted these values, and that will give us lambda E equivalent slenderness ratio 1.21. So we have that option, that we have B. And then last problem we have, determine the design axial load on the column section ISMB 400, given the height is given 3 meter and is pinned. Assume the following. So properties are given. So area of ISMB 400, we have 7840 mm square. So H by BF, now we are calculating buckling class, and for buckling class we are using table number 10. And then we have H by BF greater than 1.2, TF less than 40. And then you can see this from table 10. We have this, that is greater than 1.2, less than 40.40. So we have ZZA and YYB. We have to go for lower class, which is B only. And then we have calculated L effective at both end pinned. We have L effective equal to L. Then this is R minimum, which we have RYY, that is 106.38. So this value is not there. And then we have class B already we have seen, so we are using table 9B. And you can see for 100 and 110, for 250 we have these two values. So if I will write KL upon R, we have 100, and then 110, and FCD we have 118 and 104. And for this, again, we have actually made this mistake, 104 minus of this. And from this, we will get value of FCD, and that value we have 109.07. And if we will put area in this 7840, PD will be 855.11 kilonewton. So now 855, so it will be again in option B. So we have for 9 option B. You have to go through all problems and you have to check it, because already we have covered this compression member. So now we will stop here only. Remaining part we will see in the next video. Thank you.